Hello everyone, we are going to solve problem 87 of chapter 16. If rod CD is rotating with angular velocity of 4 radians per second, determine the angular velocity of rod AB and CB. So omega AB and omega CB are unknown for us. By looking at the problem by now, you should know that when we have omega CD here, and we know this distance, you should be able to know velocity at C. The velocity at C is 0.5, 4 is 2 meters per second. So we want to find the omega AB and omega CB. If we are going to use the IC method, we need to find the direction of the velocity at 2 points of our member BC. We know the velocity at C, the direction of velocity at B is also straightforward, is perpendicular to link AB. Now I need to draw perpendicular lines to the two velocities, and perpendicular to velocity at B would be just in the direction of rod AB. So IC would be in this location. And if I draw this triangle here, again, so we can see we have B, we have point C, in this dimension is 0.4 meter. This is our IC. So if this one is 0.5 meter, and we know the angle here is 30 degrees. So this line is along the line of AB. It has the same angle. So we know that C to IC, this dimension, would be 0.4 tangentially. And dimensions here from B to IC would be 0.4 over cosine 30. So here would be 0.4 cosine 30. So now we know where our IC is located, and we have the dimension, the length to the points of interest, C and B. In these problems that we want to find the angular velocity of multiple links, the points of interest are the points that are located at both links. So here in these problems, C and B, point C is located on member DC as well as member CB. And also pin B or point B is on member AB as well as member BC. So we can find the velocity of point C using the angular velocity that we know. And then once we know the velocity at C, then we can find the angular velocity of the member that we don't know, like member BC. So we found the velocity at C, just 0.5 times 4, 2 meters per second. Now I can use that velocity to find omega BC. So I know the velocity at C, because member C is also part of member BC, is RC with respect to IC omega BC. I don't know the omega BC, but I know the velocity at C. I already found it by knowing the angular velocity of another member. So omega BC would be VC, which is 2 over RC to IC. That would be this dimension. So 0.4 tangent 30. And therefore I have omega BC 8.66 radian per second. So now I have omega BC. I have the angular velocity of member BC. And also I know the point of rotation, the center of zero velocity, so I can find the velocity of member BC at any point. So because point B is another point of interest, because it's part of both links, I want to find a velocity of B and then later find omega AB. So velocity at B, it would be R B IC omega BC. So from B to IC, that would be this dimension. I want to find a velocity at point B with respect to center of zero velocity. So 0.4 over cosine 30 times omega BC, which we just found it to be 8.66. So velocity at B would be 4 meters per second. Now that I have the velocity at B, I know velocity of B can also be found by knowing omega AB. Here omega AB is unknown. So velocity at B is RB A omega AB. I have everything except omega A B. So velocity at B would be 4. RBA, the length of link AB is 1. So omega AB would be 4 radian per second. So we found omega AB. We found velocity at B. We found velocity at C. And we determine our two unknowns. In this problem, it's very important to know the common points. The common points here are point C and point B. We find our velocity by the angular velocity that we know, and we use that information to find the angular velocities that we don't know. You can solve this problem by a relative velocity approach as well, and you will get the same answer. Again, you need to practice solving with both methods so you would be comfortable with both approach, and then you could decide which one to use in real application.